systems of equations solving by substitution. So we've already solved by graphing, and so we need to find the solution to these, and we're looking for the coordinate point where both of these lines will cross. And so here are your general steps, and you can read these on your own. I'm going to just show you how to do the steps over here with example number 1. However, we do need to notice that this method works best when one equation already has a variable isolated. So if you already have y equals a number or y equals stuff or x equals things, this is when substitution works best. So we're going to for example 1, we're going to solve the following systems with substitution. And so we notice that we already have y is equal to 5. And so what we can do is, since we know that y is the same as 5, in the bottom equation, I can replace this y value with what it's equal to. And so we can substitute y with 5. So we can say 5x minus, and instead of writing a y, we can write what it's equal to, which in this case is a 5. And now what we have done is we have taken this equation that used to have two variables, x's and y's, and we have written it all in a single variable equation. This is something that we can actually solve down to have x equaling a number. We couldn't do anything before because we had an x and a y at the same time. So that's the point of substitution. We're trying to get rid of this variable by replacing it with something else. So now that we have replaced it and we have all x's, we're going to solve this guy for x. So I'm going to distribute this -1. So 5x minus 5 equals -3. We need to get x by itself by adding the 5 to both sides first. So 5x equals 2. And then divide out the 5 in front of the x. We get x is equal to 2/5. Now, you're supposed to write the answer as a coordinate point, x, comma, y. Well, we have the x is 2/5. We just found that. And we have the y from the very beginning of the problem. It said that y was equal to 5. So we can go ahead and plug that in for the y coordinate. And we have finished solving this system with substitution. So I want you to pause the video and try example number 2. And here's what you should have had for example number 2. We have x is 3, so we substitute that in for the x, solve this for y, and then when you write the coordinate, remember it's always the x first, so it's going to be 3 first, comma, -3/5. Now let's look at example 3. Solve the following system with substitution. So again, we still have a y that's already isolated, and it is equal to 2x. So this is a little different because now we have y equaling something with that still has an x in it. So it's not just a plain number, but the process itself does not change. We know that y is the same as 2x. So in the bottom, I can replace y with 2x. And so what the bottom equation turns into then is -2x minus 3 times. But we're replacing y with 2x because that's what y is the same as. And let's make sure this is still all in one variable. X's, this is something that I can solve down and get x equals a number. So now that we have replaced y with what it is equivalent to, we're going to solve this for x. So distribute the -3, so -2x minus 6x equals -16. I can combine like terms together. So this makes -8x equaling -16. And then to get x completely by itself, we simply divide by -8. So x is equal to a 2. Now, in the two previous examples, we were finished. We knew exactly what x was and exactly what y was. However, in this case, it just tells us that y is 2 times whatever x is. And so we still have to do one more substitution. So we know that y is 2 times whatever x is, and now I know that x is 2. So now we can replace the x in the top equation with what we previously found for the x value. So now instead of just saying 2 times whatever x is, I know that x is 2. And so that y has to be 2 times 2, which makes y being a value of 4. So now we have the two numbers that make up our coordinate. The x is a 2, the y is a 4. So pause the video, see if you can try out example number 4 by yourself. And here's your answer for number 4. Let's try example 5. So for example 5, we're getting a little more complicated. We still have a variable that is isolated. We still have y completely by itself, but now y is equal to not only a number and x, but also a number x and then subtracting another. This is kind of getting complicated. The process does not change. We're still going to replace y in the top equation, what it is equal to, with at the bottom. And so on the top equation, negative 5x minus 17 is going to replace the y in the top. So the new equation at the top is going to be negative 3x minus 3 times whatever y is. In this case, y is negative 5x minus 17, and then equaling up to 3. So the only thing that changes in the top equation is what you are replacing, which is the y value in this example. Now that we have everything in all x's, we can solve this down for the value of x. So distribute your negative 3. So negative 3x, and then negative 3 times negative 5x is a positive 15x. Negative 3 times negative 17 is positive 51, equaling 3. Negative 3x and 5x are like terms, so 15 and a negative 3 will add up to be a positive 12x plus 51 equals 3. And now we can start solving for x. So subtract 51 from both sides. So 12x is equal to 48, negative. Divide out the 12, and we have x is equal to a negative 4. And so here's the value of x. Again, we still need the value of y in order to create our coordinate as our solution. And if we look at our original problem, we have that y is the same as negative 5 times x minus 17. So I can use this to help me find the value of y. So now we're going to take the x value of negative 4 and plug that back into one of the original equations in order to find the value of y. So we get negative 5 times negative 4 minus, well, negative 5 times negative 4 is positive 20, and 20 minus 17 makes 3. So the y value of the solution is 3. So to put it together as a coordinate, we have negative 4 as the x, comma, positive 3 as the y. So I want you to pause the video, and I want you to try example 6. And here's your solution for example 6. So we do end up with a fraction for the y value, but it's going to work the same as it would be if it was a whole number. And this is also where solving by substitution is better than maybe graphing, because this is an exact answer. Trying to solve by graphing, we may not get the exact, we may be able to round a decimal, but we may not be able to get the exact solution in the fractional form. Let's look at example 7. So for example 7, I have two variables isolated. I've got y equaling negative 3x plus 4, and I have y equaling 4x minus 10. So even though that two sets of y's are isolated, we're still going to follow the same process. This y is alone, and y is equal to negative 3x plus 4. So we're going to take negative 3x plus 4 and replace it with this y at the bottom. So what this turns into is negative 3x plus 4, that was the replacement of the y at the bottom, is equal to 4x minus 10. We have taken this here and replaced it with this y here. And now that we have an equation in all x's, we can solve this for x. So we need to get all of our x's to one side. So I'm going to add the 3x over to get the x's all on the right. So we get 4 equaling 7x minus 10. We need to get the constants to the other side, so add 10 to both sides. So 14 equals 7x, and then divide out the 7 to get x is equal to 2. So now that we have the x value, again, we need to take that x value and substitute it back into one of the original equations. However, both of them have y by itself, so it really doesn't matter which one you substitute into. So I'm going to substitute into this bottom equation here. So I'm going to rewrite the bottom equation, y equals 4x minus 10, and I'm going to substitute 2 into the x. Substitute 2 into the x. So we have y equals 4 times 2, which is what x is, minus 10. Well, 4 times 2 makes 8, and 8 minus 10 makes negative 2. So the solution as a coordinate point is an x value of 2 and a y value of -2. So pause the video, see if you can try out example 8. And here's what you should have had for your solution for example number 8.